huge group of people out here in the entranceway to the RI, if you'd like to come out and join me.
Sure thing.
So thank you very much, everyone who came along bizarrely all wearing red hats. That's fantastic. And all of you wearing yellow. Wow, how fortunate. This must be the new fashion. So we're going to try and experiment with all of you in a moment to see what happens when you're moving through a crowd.
Okay, when you're moving in a crowd, I mean, everyone's making their own decisions. It's random, surely.
It feels very random, very chaotic, unorganized. You're being bounced around. However, there are some patterns, and actually, we want them to walk naturally, so we're not going to tell them when the experiment starts. So, ready, watch this. Actually, I'm really sorry, everyone. We've just realized, don't move yet, that we wanted the yellow hats on this side. We wanted, I know, the red hats on this. Not me, it's coming from upstairs. So I think we're clear. Okay, if you can, quick as you can, if you just swap over sides, exactly where you are, but opposite across. Okay, so you can see here, we've got an overhead camera rigged up, so we can see. Come on, everyone, as quick as you can. Hurry up, come on, faster, please. We've got a TV show to do. Here we go. So
they're not all jumbled up.
It's not random, is it? Right? Look at this.
So
having
because
some wild issues here.
Everyone's just following each other, and you end up with these very clear lines.
So if these were random, it'd be a complete mix. Instead, we've got these fantastic stripes. Come on, everyone, let's keep it moving. You end up with these fantastic stripes. Look at that. So everyone, that was fantastic. Thank you so much. And that was the experiment, so thanks very much for getting involved.
Thank you, Matt. Now, it turns out there are actually a lot of similarities between the maths of how people... Be quiet down there. How people flow through a corridor and how fluids behave. And if you can understand how people move when they're in a crowd, you can predict how they'll react in the case of an emergency. And that's something that's incredibly important if you are designing buildings or stadiums or train stations to make sure that your design is as safe as it can possibly be. And that is the point. That is what math is all about. It's all about discovering those invisible patterns, like this beautiful pattern left here by that swinging pendulum. Isn't that gorgeous? Much neater, I think, than you would expect. But you know, math isn't just about spotting patterns. It's also about using them to your advantage. So here is something that might look as though it's random. Best part of Christmas, obviously. Who gets the toy? Who gets to wear the hat? Now, here you go, if you want to have a go on this. Because you only do this, go for it, a few times a year, you may not notice. There we go, you can have that one. You may not notice that there is actually a pattern to this, but luckily, I've done hundreds of these, and there is a knack to winning that I can explain to you. So what you do, I'll teach you right, and then I can show you. So what you want to do, you want to hold your end lower than the other person, use two hands with a really sort of steady, firm hold, and you don't want to do any twisting or pulling. You don't want to really tear this. So what you're trying to do, ultimately, you're trying to let the other person do all of the work, so that then, you end up winning. Well done. You can have the hat now. Enjoy. Now, I've got to be straight with you. This isn't going to work every single time, especially not if your opponent knows the same trick as you and you're just steadily trying to get lower and lower than the other person. But the maths of prediction isn't about saying what's definitely going to happen. It's about considering all of the possible outcomes and working out what's likely to happen.